Okay, are you all right now? Can see the picture?
Yeah,
Okay, let's summarize for you what is it in topic 7 waves. Right? If you are looking for the question paper I've sent you earlier, right? There's a question paper. Past paper I've sent you. Right? I'm just taking it from there and choose which question to cover as much as possible the syllabus. Okay,
yeah,
okay, let's start waves. Okay, only this formula is given, right? Doppler effect. All this formula you need to remember. This one not necessary lah. They will tell you lah. This one is distant from the point source. R is a distance from point source. This one from here. For Doppler effect, this is a formula that is given. Right? Know what is this? The speed of sound, frequency of source, speed of source. S is for source, and you choose negative when the source is moving towards the observer. If the source is moving towards the observer, basically it is of this case where the speed of sound and the speed of the source is in the same direction. That's why you choose negative. Right? Or you use this picture to help you. Right? It's moving towards the observer, the wavelength is shorter or frequency is higher. And then law of Malus apply to polarized light. Right? Not apply to this one. And polarized light, but polarized light, it passes to a polarizer. Then this is I naught. And then that's coming out is I1 equals to I naught cos square theta. Okay, page 254. You have to choose whether you memorize wavelength emitter, or you prefer to memorize in terms of frequency, right? But for visible spectrum is 400 to 800 nanometer roughly rough guide 400 is violet, 800 is red light, or I prefer the exact one up to you your choice. Okay, what's your answer for this one? X is ultraviolet, Y is microwave. Yep, all this must be in your fingertips already, on your fingertips. Memory work.
B.
A.
Oh, oh,
Okay,
yeah,
memory work. I use a visible light micrometer. So ultraviolet will be here, smaller wavelength. Microwave, longer wavelength, 10 to the power minus 4 to 10 to the power minus 2. Okay, Which of the following gives three regions of electromagnetic spectrum in order of increasing wavelength? Yep.
Increasing wavelength. Gamma. Yeah. A.
A is wrong.
Wait.
It should be gamma
Oh,
ray,
depends on the
visible,
power.
microwave. B is wrong. It should be X-ray first, ultraviolet, radio waves. C is the correct one. Donkey is also wrong. Should be gamma ray first, then visible radiation, then radio waves. Okay,
Yeah.
this memory will also X and Y. X in the infrared, Y ultraviolet region. As usual, go to visible light, 0.4 to 0.8 micrometer. Ultraviolet is shorter wavelength, is less than 0.4. Right? Ultraviolet less than 0.4. So this is about there. Then infrared, higher wavelength, right? Greater than 10 to the power minus 6. It's 10 to the power minus 5. A. Okay.
Yep.
Which value is the possible radiation in microwave region? Yeah, we just did that. So you should be able to remember. Yep, what's the answer?
Radiation.
A. Memory work, nothing much.
I just have to memorize the wavelength of each of the waves, like times 10 to the power of what is it?
You have to memorize it, no choice. As I have said, either you memorize it, this diagram, in terms of wavelength or frequency, or you memorize the exact one. Okay,
Yeah.
no choice. You have to memorize it. Right? Sometimes you come out as frequency, infrared. And remember,
Infrared.
C. Okay, 10 to the power 11 to 10 to the power 14. Memory work, nothing can teach you about that. You have to memorize it. Okay, number 8. And number 8, you have to use your head a little bit. Electromagnetic waves of wavelength lambda, frequency f travel at speed c in vacuum. Which of the following describe the wavelength speed of electromagnetic waves of frequency half the original frequency? Yep.
C. Answer is C.
What's the answer?
C. Cat.
C, correct. Okay, good. Speed is constant. Right? F and lambda are inversely proportional. There is 2 lambda. What do not travel at the speed of light in vacuum?
Um. Should be X-rays lah. In radio waves, radio waves.
No, all electromagnetic wave travel at the speed of light. Only electron doesn't travel at the speed of light.
Wait.
Near the speed of light, but not the speed of light.
Oh.
Right? That's under nuclear physics beta particle.
Yeah, but electrons also is a bit like lights, right?
Say again.
Like the thermionic emission, like the electron beam also act as a light.
No, electron for your electromagnetic radiation, they are waves. Electron is electron.
Oh.
If it's beta decay, it doesn't also reach the speed of light. It's quite close only. Okay.
Yeah.
Okay, let's go to waves. Memory work. Right, go and download from YouTube and then review it if you are still not ready yet. Yep. What's the answer? Memory work only. Answer is B.
Oh.
How about this one? Right, we just went over that. What's the answer?
I think it's infrared to UV increases and then speed remains constant. C.
Oh, C. Okay, good. Right, all electromagnetic waves travel at the same speed. From infrared to ultraviolet, the frequency increases. Okay. Which of the following is true of transverse wave?
Was
Yep.
C.
Transverse wave, not all can travel through vacuum. Sound wave, transverse wave will be water waves. Water wave need water as a medium. Right?
Oh.
Can be water waves, electromagnetic waves. They are all electromagnetic waves. Not necessary. It can be water waves. Or I say you need to transverse wave only. So the answer is B. They can travel through vacuum. False. Only electromagnetic wave can travel through vacuum. They are all involved in oscillation of atom. False. Electromagnetic waves are due to oscillation of electric and magnetic field. Okay, what's the answer? Yep.
E. Boy.
Not necessary. Longitudinal wave can also be represented by that. Amplitude is 2 cm. That's amplitude. That's your period or second. Right? Answer is A.
Oh.
Okay. It's just a displacement time graph only. It doesn't tell you much. It can be transverse wave. It can be longitudinal wave. Okay. Number 10. Right? This is a
E.
displacement time graph.
Donkey.
So Q, the gradient there is horizontal. So it is stationary. No? So what's the answer?
Donkey.
Right? Let it be displaced slightly. P is moving downwards. Q is stationary. Right? A.
Wait, how?
Okay now. A is moving down. It is here. After that, it's moving downwards. Whereas Q is stationary. It's not moving at all. Remember, this is a displacement time graph or displacement distance graph. So the gradient is the velocity. Okay? Yep. What's the problem?
Wait, I don't understand the question.
The question is they want to know P and Q. How are they moving? Describe the which of the following describe the direction of motion, if any, of points P and Q at this instant. At this instant, when the wave is passing through P and Q, where is it moving? It's going to move downwards. Right? It let it displace. It is here. After that, it will be going there. That means moving downwards. Whereas Q is stationary. It's at the highest point. It's oscillating up and down. So at the maximum point, it's stationary.
Oh, but I thought P is about to go up.
No, as you can see, the wave is moving to the right. Right? P is moving down, not up. Okay, let the wave be displaced slightly. Yep.
Ah,
Okay, okay, try this one. This is formula. I is Ka square. My X is 20 square. K 20 square. Y is 5. As long as you use the same unit, yeah, all right. No need to change it to meter. Then cancel 5 and 20. Cancel this, count
P.
4. 4 square is 16. Yep, can.
Yeah.
What the answer? Write down the equation, no? Right? P is I naught. Right? Yeah, 2 is square of frequency, proportion of frequency. So frequency is inversely proportional to your period. That's why we put T naught, divided by T naught. And then the whole thing square. So X naught over T naught. Then for wave Q is K, amplitude is 2X naught. T naught is 2T naught. 2 and 2 cancel, they are exactly the same. Right? They are exactly the same. So I equals to I naught. Lor. The answer is B. Okay, now
Yeah.
try this one. Yep. Why it takes so long?
Wait,
Find the wavelength, no? Use this equation, right? Calculate the wavelength, and then use this equation to calculate your phase difference. 0.17 meter. Wavelength is 0.68. Is 2 pi. So it's pi volt. Answer is B. No? Okay now.
wait, ah.
Anything don't agree.
Yeah,
Pi is
phi
in
is the
radian. 180 degrees. Pi radian.
no phi
Pi is a phase difference. No?
phase difference.
Phase
Oh,
different. Phase different.
then should you use two
You have
pi
to
or should you
memorize
use
this
three?
formula. This formula.
Should you use 2 pi or should you use 360?
You use wavelength, we didn't learn frequency, so you have to convert this information to wavelength, because it's the distance is in meter, so you have to convert to wavelength.
Oh, I mean, do you use degree or radian for the 2 pi?
2 pi is 360 degrees.
Okay.
You are AS, you don't require to use pi. If it comes out, it will be in degree. But you still need to know how
Oh,
to
I see.
calculate. Pi radian, then you have to do in A2. This is an old question. That's why old question they are required to know radian in AS. Yep. What is the problem? Anything don't agree? Calculate wavelength
Uh,
first, because you want the difference between 2 points on the wavelength. Okay.
uh,
Yep. Phase difference between x and y can be expressed as n pi. Right now, pi is 180 degrees. 2 pi is 360 degrees. Then read x is 90 degrees or half pi. Y is y is 2 pi to 3 pi, 3.5 pi, 3.5 pi. The subtract is 3. The answer is C.
yep.
Yep.
Is it B?
Acceleration as at S is maximum. Yeah. Donkey. This is simple harmonic motion, where the displacement is maximum. The acceleration is, in a sense, is maximum also, but it's in opposite direction. So answer is donkey. Okay.
Oh, yeah.
You will study more in detail in simple harmonic motion. Okay, what's the answer? Playing with the formula only. Yeah. Right. Intensity is proportional and amplitude square. So take S across there. This is a constant. Or AX is a constant. So A2 is a X1 over X2. Okay. A is
Okay.
amplitude. Remember, A is amplitude. Amplitude is A. As long as you use the same unit, all right. A, you get, if you use micro, you get micro. X1 is R, X2 is 2R. Okay,
Yeah.
donkey. Okay, let's try some structure question. Have a look at the graph. Okay, answer the, have you read the graph? State what is meant by transverse wave.
Transverse. Ayo, forgot.
Either you can describe in terms of energy or you can say transverse wave. You got 10 more minutes. When transverse wave pass through a medium, the particles of medium vibrate in direction perpendicular to the direction of travel of the wave. So what is the frequency?
So means it, up and down, is it?
Perpendicular. The vibration is perpendicular direction of travel of the wave.
The opposite of transverse would be longitudinal.
Longitudinal will be the vibration of the
Other side,
particle will be parallel to the direction of travel.
Oh, I see. All right.
Right? All this must be in your head.
Yeah.
Okay, how to calculate the frequency? Read the period. Right? Period is 5 milliseconds. Frequency is 1 over period. 5 milliseconds. Convert it to second is 10 to the power minus 3. By the 10 to the power minus 3 or 1000 over 5. So it's 200 hertz. Okay,
Yeah.
intensity in terms of I for wave T2. A second wave, a second similar transverse wave T2 has the same frequency, but amplitude of oscillation due to T2 is 3A over 2. 3A over 2, this is A. So what's the answer? Right? Use this formula, play with the formula. Right? That's the new amplitude. It's 9A square. 9A square over 4. So KA square is I. State two conditions which are necessary for two waves T1 and T2 to interfere destructively. What are the two conditions? Yep. For them to interfere destructively. Same type of wave, same amplitude, same speed. Any two of them. Okay, not?
Yeah.
calculate in terms of I, the intensity of the resultant wave when I1 and I2 interference destructively, right? This is A, this is 3A over 2. So calculate the resultant amplitude, 3A minus 3A, half 3A minus 2 is half A. So nu is K, this is your half A square. So KA square is I, so it's a quarter I. Can or not?
Okay.
Variation with time t of the displacement x of a point at transverse wave t is shown in figure 5.1. By reference to displacement and direction of travel of wave energy, explain what is meant by transverse wave. Right? There's simple mark for you to gain. What is meant by transverse wave?
Oscillate perpendicularly to its line.
Displacement
Yeah.
and direction of energy travel in normal to one another. Okay. Hey, make sure you try the recent past paper from 2022 onwards. You can download it
Okay.
from the internet. A second wave, T2 of amplitude A, has the same waveform as T1, but lags behind T1 phase of 60 degrees. The two waves, T1 and T2, pass through the same point. On figure 5.1, draw the variation with time t of the displacement x of point in T2. Right? That's the original wave. Right? Calculate, change it to time because this is in time. Right? We have told phase lag of 60 degrees. So cross multiply by 3, 60, so it's 0.5 seconds. All points are displaced 0.5 seconds to the right. Okay,
Yep.
use figure 5.1 to determine in terms of A, the displacement due to wave T1 alone. Right? This one is reading from the graph itself. Right? 1 second. 1 second is here. Read from the graph itself. Right? Negative. Displacement due to T2 alone. It is T2, the blue one. T2 alone. Right? T2 alone. 0.5. Right? Resultant, you just one subtract the other one. Right? Add the two together. One is going up, one is going down. Same amplitude, so it's 0. Okay.
Yeah.
Determine for the wave, the amplitude and the wavelength. Yep. What's the amplitude?
Video is 0.4.
Okay. Wavelength.
Thing is
A bit difficult to read lah.
0.2. Wait. Yeah.
You have to use this graph lah. 4.2 to find the wavelength. Right? Frequency have to use the previous graph from here. Frequency
2.2 what?
right? You have to
Oh,
find the period. Right? That's a period. And frequency is one of the period. Speed is frequency times wavelength. Okay.
yeah.
And then in figure 4.2, draw a second wave having the same amplitude but half the frequency. Right? So the original frequency is that, half the frequency is 220. So if you are asked to draw from 4.2, you want the distance, so to convert to wavelength, frequency to wavelength. So that is the speed divided by wavelength is 15 cm. So that's how you draw. Yep. Can or not? Same amplitude, wavelength 15 cm, 15 cm. Yep, yep, yep.
Yeah.
You want a class on Thursday?
Yep.
We will revise superposition. Depend on what time you want to start. If it's too late, we just have 40 minutes. We have less than 1 minute. So you want to discuss anything, you can discuss. Want to talk about anything, can talk about anything. Anything